So before we'll get into these topics, let's quickly recap what we have learned in previous session. So let me go back to this. So what we have seen last time is how we scale our web tier, where we put two web servers under auto scaling group. It was under VPC and having private IP addresses, which can be accessed by load balancer and only by load balancer. And the public address provided by DNS was public address of load balancer. And we also looked at what is vertical scaling, horizontal scaling, and load balancer. So this is something that we looked at it, and definitely all these topics, I'm just taking a higher overview of it, but later on we will get into more and more details of each of the individual components. Then what we have looked at it is the database replication. Where we have seen we have created two different kind of databases. One is master, another is slave, and how we send the request, especially the read request to slave databases and the write request to master database. And there is a continuous database replication happening between master and slave databases, and how the failover will be taken care at the slave database, and as well as some strategy for master database as well, like a slave will become a master. So we also looked at it. And what is also the advantage of having the replication, that also we've seen. Moving on to the next, this is what we have seen. The overall design will look like. The load balancer got added. The web tier is under auto scaling group so that any failure will be taken care, and as well as the read and write operations to the slave and master database and the replication between them. That is also we have seen. And now this will help us that web tier and data tier will not be a single point of failure, and there will be immediate failover action will be taken by the system itself. So now system is more available. I'll say more reliable. It's not the right word, but maybe it's more reliable, we can say, and also fault tolerant. So that all the, if even any component of the system goes down, immediately the action will be taken by the system, and the next server, next database will be placed on the failed components. Right. So now moving on to the next topic, it's called cache. So I hope you all are aware of cache, but still I would like to put some words here. Like we do day-to-day coding, and you imagine, suppose you are writing an application, you define some variable, you assign some values to those variables. But till the time your program is running, the variable will carry that value with it, and the value will be remain with that variable. But once your program stops, the value goes off, right? Until and unless you save that value from your variable uh, to a permanent storage like hard disk or pen drive or any other place which can be stored your values permanently, or maybe a persistent data that you can create through it. So but cache is something differently. Cache is like a RAM. Mainly it is a RAM where the data gets stored, and it will be remain there until unless the server is working fine. If server goes down, this data that is stored in cache, that will goes off. So just I have put a quick definition here. A cache is a temporary storage. As I mentioned, it's like a RAM. It's a temporary storage that stores the result of expensive responses or frequently accessed data. Now, what do you mean by expensive responses? Means the responses, like you send a request to your web server. Web server will send that request to another server, which will do some kind of calculation. Then that service, I mean, that particular server or service will send some request to database, one or multiple databases, where it will receive some data, then it will again do some kind of calculations, and then it will respond back to your request. So that is lot of calculation or lot of responses, like request and response going behind the scene once you request to a web server. So that time is usually called as an expensive responses, because it is going to take much of the time, not like just getting a HTML response. So such kind of response we usually can store in cache, or most frequently access data, like you access similar pages like just imagine gmail.com or maybe a google.com. So you try, you maybe always every day you access those pages. So those pages will get stored, like the frequently accessed one will get into stored into the memory. So these kind of frequent requests, so that we can server can serve you quickly, those get saved in cache. But again, I'm mentioning that cache is a temporary storage. Okay. And temporary storage means the data is not persisted. Data is available until unless the server is working fine. If server goes down, your data will go down. And in that case, your request has to go back to the database. So let's look at a quick workflow so that you will understand better. So I mentioned here, as I've shown something like what is the workflow. So just imagine you are sending a request to your web server, and web server, what it will do is first it will check the data, the requested data in cache. If the data is available in cache, then the request means the data will pass from cache back to the web server. So web server will immediately get that data from cache itself and it will send it back to the user. But the third step that it is I mentioned, but if data doesn't exist in cache, what it will do, it will request data from database directly. And database, while sending the response, it will save that data to cache first, and then cache will send that data to web server. So here you imagine like this particular strategy, there is a name for this strategy. It's called read through cache. Like you always first ask cache, and if cache is the have data, it will give you back. If it doesn't have, then the request will go to database, and when data will this will send response, it will first save it to cache, and then the request, the read data will be send it back to the web server. Okay, so but here when we save data in cache, I have also mentioned with TTL. TTL stand for time to live. So just imagine your cache data is stored in your cache from which is we pulled it from database, but that cache data after some time it will become it will not be a latest data. It may possible that data is old enough and the data has already been updated in database. So that data should get expire or it should get removed from cache. And whenever same data is needed, then again request has to go back to database and it will latest data will get saved to your cache. So that data should change. Your cache should get updated with the latest data every time. So the time to live is certain kind of times, maybe half an hour. That time to live is mentioned in when we are saving the data in cache. For example, usually data stored in cache in key value pair, like key will be maybe my key and data will be hello world. I'm just giving some vague example. And along with that, we can mention how much time this data, this key value pair should stored in cache. That may be a 60 minutes or 30 minutes or something. And after that time, the data will automatically get removed from cache. And next time, whenever server will request for the same data will not be available with the cache, then request will go to database and the new data will be written back to cache. Okay, so that is the whole purpose of this cache. First thing is that it should give you a faster response. That's why the cache layer or cache tier is there in between, so that you will get quicker response for frequently accessed data and as well as expensive responses. There's one more thing that I would like to mention here, that there are different consideration we should give, like uh, whether we should use cache or not, what exactly do we need, like when exactly do we need, or what is the purpose of cache, that also need to consider. For example, as I mentioned, the frequently accessed data is there, it should store, but it is not a persistent store. Persistent store is a database. But whenever you have cache and you want to give a quicker response, the data should be only which is frequently needed or frequently requested by user. That data should be stored. Okay. Second, as we discussed, TTL should be there because it's important that the data should expire and get removed from the cache, and the latest data should always get stored in the cache. So there will be expiration policy should be there. So that is through TTL. You can decide, like the time varies. It may be few seconds to a minutes, but it depends on the kind of architecture we have, the kind of data we need, the kind of request that we get. So it all depends on that. So that consistency we can manage between the cache and the database with having this kind of expiration policy. And that consistency is needed. Okay. Apart from that, there is one more thing that is usually we look at it. It's called cache eviction policy. Just imagine that you filling the information every time from database to cache, and cache get full. So if new request is coming from database to cache and we are storing something new, so anything like whichever is there, maybe whichever is added first will just be taken off from the cache, which we will need. Maybe user is requesting more and more, and that particular request or data is not available in the cache because it got removed because the cache was full. So in that case, we usually follow kind of eviction policies. It's called, for example, I'm just giving something called LRU, that is called least recently used. So those least recently used data should get removed. So that is one strategy. So whenever we have to remove something from cache, we should follow this cache eviction policies. There is something called LRU, as I mentioned. There is something called LFU, least frequently used. There is something called FIFO, first in, first out. So these all depend on the situations, depend on your design, depends on your design requirements. You should use these strategies. But so the cache should be updated and available for every time. See, again, if you look at this particular design, we have a single cache. Again, this will be a single point of failure. So again, we should have multiple cache servers, which will be like active and passive, or maybe multiple passive, or multiple active. So both multiple possibilities are there for cache as well. But you should look at what kind of design do we need, what kind of problem that we are solving. Like it is applicable to all the components, and how you will tackle each and every problem. What kind of strategy that you will use to save data in the cache, and how the cache will be available every time to serve the purpose. All right. So any question on cache? If not,
No.
then I'll move ahead. Yeah, Anushka. Okay. All right. So let's move to CDN then. So CDN, again, I mentioned here is CDN is a network of geographically dispersed servers. So just imagine CDN is again a server which delivers static content. So I'm emphasizing on static content. What is static content? Like you imagine that here I have also mentioned that we need, suppose I'm accessing Gmail or I'm accessing uh, some website which have some static information, like there are particular image available, some videos or some CSS file or JavaScript files. So these are something called which are not changing over the period of time, which are remain static maybe for a day or maybe a week. The data is not going to change. So such kind of information, you imagine that geographically, if you have a website which is working, like which you put it on internet in somewhere in Asia servers, and someone from US or European region, they are accessing that information. So imagine that when they're accessing information from a server which is located in Asia, they will definitely get lot of delay in response. Even though servers are faster, servers are able to deliver all the requests, and we have auto scaling group, we have databases, multiple database, even we have cache, but still it will give some delay in response. So in that case, what usually has been done is these CDN, these servers are placed close to the particular region where user is located. So we may have, for our website, we may have a CDN located in somewhere in Europe, somewhere in US, maybe North America, or maybe South America, or maybe uh, somewhere again other place of Asia. So user can do one thing is whenever they will send request, this suppose just look at this diagram. User A is requesting through his computer looking for a image.png. Okay, the first step. It will user is looking for image.png, and the request for first will go to CDN. CDN will check whether request means the particular information image.png is available with the CDN or not. If not, then the CDN will send that request back to web server. That web server will send maybe to internal database somewhere like Amazon S3 or some blob storage. That storage will again send that image back to CDN with TTL, with time to leave. And then CDN will send back that information to the user, to the user A. So you can see fourth number step, the user got that information. Later, in the same region, suppose in Asia region itself, user B is trying to access this information through mobile client, and it is requesting, get me the image.png. The request will go to CDN, and CDN already cached that image.png, so it can immediately give you that request. So that is the purpose of CDN. And I talked about the same region user, but it may possible that user B is from completely different region. Maybe it's user B is located in Europe. So in that CDN, again, the first time the request will send back to backend server, it will take the information from the backend database and it will store that in CDN, and then CDN will serve the request. Okay, so that is the whole purpose of CDN. CDN is located at multiple locations at uh, multiple data centers all over the world, and your data will get saved accordingly according to the request that you get. But just trying to mention and emphasize again that CDN is mainly to store static content. That is the information that is static. But again, there is a possibility that this static content get changed over the period of time. Maybe in 2 days, 3 days, or 15 days, the information is not same, which is on CDN as well as on the web server. Maybe web server or database already updated with the new information. So that's why again this TTL, time to leave, is there. So that after some time, the information on CDN will get expire, and that information will get automatically removed from CDN. And then whenever the next information will come, CDN will again send request back to web server, get the latest information, and it will store back to the CDN. All right. And it is, again, these all cache and CDN is just to make sure that user should get faster response, an immediate response. So that is the whole purpose of it. Imagine that maybe a request that is from user A going all the way to server which is located in somewhere in US, and you get response in maybe 200 milliseconds or maybe 1 second, imagine. And if the information, same information is stored in CDN, that will give you that same request in 40 milliseconds or 50 milliseconds. So it will be vast difference between them. We're not able to measure that difference, but definitely the response will be much quicker. Just imagine if you are going to a website, suppose google.com. If your laptop is new and you are going and typing google.com or maybe gmail.com, you will get response with little difference, maybe 1 second or 2 second max. But next time when you refresh the same page, the page will get reloaded very quickly because it has been cached. And that's why the request has been served very fast to you. So that is the whole purpose or whole idea behind this. And regarding this CDN, I just want to mention one thing, that there is also a cost involved in CDN. The reason is CDN is usually run by third-party providers, and whatever data goes in and out of CDN will get charged. So you should be very sure that CDN is having only static content which is most frequently used. Otherwise, it will be a costly matter. Okay, and again, as I mentioned, time to live is there, so that this CDN is again kind of cache which will get expire, and data should be consistent with the web server. So you are delivering the latest information to the user. Okay, so this is what about CDN and cache. Do you have any question on this? No? Then let's move to the overall design. Okay, so now our design has few changes. We have seen our load balancer, web tier, data tier in our last session. So now you can see the CDN is added before, it's not connected with load balancer. But there are sometimes we also put load balancer here somewhere between CDN and client. And there is cache also added after web tier. So again, I mentioned here static assets like images, videos, CSS, JavaScript files are normally not, usually it used to serve by web server, but now they can be fetched through CDN itself. So what exactly purpose of cache and CDN is to see to it that database will not be overloaded by the request. Because many requests that are going through load balancer to web servers and all the way to database, and again you're getting this response. It is the costliest transaction, I'll say. So we are trying to see that how we can make sure that database is not overloaded. Not many requests are passing to the database, and only when we are writing something, even while writing also, sometimes we write through cache. What we have seen previously is read through cache. Sometimes we also do something called write through cache, where information written in cache and database at the same time. So those strategy will look into it. But at this point of time, you can see now our left hand side is same. I'm accessing myweb.com. DNS will give me the IP address. The IP address will be of load balancer or CDN. It depends on how you configure. But CDN, if there is static content that is needed, the client will read the information directly from CDN. And if there is an application logic involved, then only the request will go back to load balancer. Load balancer will send that information to your web server, and web server will provide some application logic, which is under application web server itself, or there will be another application server which is handling the different calculations or logic behind it. But if there is a request that needed, then even web server can send that first request to cache. It will read from cache if the cache have that information. If not, then the read request will go to database, and then database will give that information back to web server, whether it is coming from database or cache. But mainly it is served from cache, and cache is not a single cache. Again, I'm mentioning it prone to single point of failure. So cache also a multiple cache, and CDR also will have a failure for sure. CDR also not single server will be there. There will be multiple server. Those are serving you the static content. Okay, so this is the overall design. It looks like now we have seen that how we are giving the responses faster, how the system is available through web tier and data tier, how data is stored. Even the one database goes down, multiple databases are available for slave and master. Multiple web servers are now available. Even you can imagine multiple cache servers are there, which delivering uh, content to web tier in a faster response, and as well as CDN is also there. So now our complete design. I'm not saying now this is full design. It is still there are many components are missing, many concepts that are we have not considered or some design consideration. But at least from basic point of view, these are the different components of a system. And we'll get into more details of each and every component later on. But this is how it look like. And this helps us to serve better to a user, and the system will be available, system will be reliable, and it will also be a fault tolerant, so that it will be serving the purpose or serving the users, whatever request user is sending. Even one or more components of this system are failing, still it will keep on serving you the results. Maybe sometime one web server will be overloaded, one database will be overloaded, still it is serving you the results. There's one more concept that is remaining in this is how the multiple data center come into picture. Like we have seen at the time of CDN, I talked about multiple data center. So that is something we'll look into it later on. But this is how currently our design looks like. So do you have any question at this point of time? If not, then I'll stop sharing.